A wire of resistance 4 ohm is stretched to twice its original length. What would be the resistance of the stretched wire? When a wire is stretched to twice its original length, both its length and cross-sectional area change. So the resistance R of a wire is given by R is equal to rho L by A, where rho is the resistivity of the material, which is a constant, L is the length of the wire, and A is the cross-sectional area. If the wire is stretched to twice its original length, the new length L dash becomes L dash is equal to 2L. Since the volume of the wire remains constant, the product of length and cross-sectional area remains the same. Initially, the volume is V is equal to LA. After stretching, the new cross-sectional area A dash will become A by 2. Substituting the new length and new cross-sectional area into the resistance formula, we get R dash is equal to rho L dash by A dash, which is equal to rho into 2L by A by 2, which is equal to 4R. Given the original resistance R is equal to 4 ohm, the new resistance R dash will be R dash is equal to 4 into 4 ohms, which is nothing but 16 ohm. The resistance of the stretched wire would be option C, 16 ohms.